I will discuss about the RCC. As we know, the RCC is reinforced cement concrete. Mainly it is having two materials. First material is steel and second material is concrete. Now the main reason that we are having in RCC steel and concrete, because both are having thermal coefficient, expansion coefficient, similar more or less. Coefficient more or less same. For steel, in general, it varies from 11 to 13 into 10 raised to minus 6 per degree centigrade.
Hello.
And for concrete, it is 10 to 12 into 10 raised to minus 6 per degree centigrade. So this is the main reason that we are having this combination of two material, and it works very well. For concrete, for RCC, we used to use the IS code IS 456 2000.
Basically, उद्याची लिंक करूया.
Hello. I am audible, na?
Yes, sir.
Okay. In general, there are three methods for RCC to solve the problem, or we can say practically also we are utilizing these methods frequently. All of these three methods are WSM, working stress method. The second one is ultimate load method, and the third one is LSM. Nowadays, in general, we are using. So, main difference between all the methods is in terms of design and analysis. Suppose we compare them, then WSM, ultimate load method, and LSM, limit state method. In terms of design and analysis, there are two parts in any design. Then for WSM, the design is done for working load. In ultimate, it is for ultimate load, ultimate method. And LCM, we are also using ultimate load. Load which is multiplied by some partial factor or some factor. And for analysis, in working stress method, we are using working load. Then for your ultimate method, we are using ultimate load. But in LSM, this is the beauty of LSM, that for analysis part, we are using working load method. That is why it is the most rational method, limit state method. Ultimate method generally we are using for, it is for ultimate load. Generally for steel structures it works, but ultimate load method, ULM, is not more suitable for the RCC structures. Better way, we will give the notation ULM, ultimate load method. So this is the main difference between all these methods. Now in general, we are using LSM. It is popular because it is more rational and economical, and we can say more popular. So we are using some partial safety factors in LSM. Today I will talk about the LSM. Partial safety factor for concrete, we are using 1.5. And for steel, we are using 1.15. There must be some reason that why we are using 1.5 and 1.15. The reason is that in general, our civil engineering, and especially for the structures, we are using some probability theory. And our probability theory is 95% success. Because as far as an engineer, we want our safety also. 95% success, 5% failure. This is our ideology for the designing. That if anyone will ask that how much success guarantee you are giving to 95%, and 5% failure chances are there in our method. So for that, for concrete, the partial safety factor is 1.5, and for steel structures it is 1.15. For same thing we are using for characteristic load and characteristic strength. FCK, you know, characteristic strength of concrete. This notation we are using. In general, suppose in terms of beam, I will talk. So it is cross section of a beam. There are two sections, longitudinal section, cross section. So in top, we are providing nominal bars, and here main reinforcement. Always remember one thing, you have to feel the reinforcement. Don't make it like this. It is not the correct way. And something like that, you have to show the stirrups like this one hook. Here, this is your B. B is nothing but width. D, overall depth. Overall depth. And one more thing is there. We have to provide side reinforcement. So many times they're asking the question. If you see the papers of ES or GATE, it is a very popular question. Side reinforcement. Side reinforcement. When it is provided, so for if torsion is not considered, capital D is equal to or greater than 75 mm. And if torsion is considered, this is a popular question of competitive exams. When we have to provide the side reinforcement in the beams. So if depth is more than 750, we have to provide side reinforcement. if no torsion considered. Without torsion, no torsion. And if torsion is considered with torsion, then it will be if 450 are greater than 450. And for that, reinforcement is provided. That is also a popular question. 1% of wave area means gross sectional area B into D. 0.1 divided by 100 multiplied by that much reinforcement has been provided, and it is somewhere here it is provided. Side reinforcement. This is known as side reinforcement. Side reinforcement. It is the main steel in the bottom. These are the anchor bars. Anchor bars. Just to hold a stirrup. This is your stirrup. And from top to up to the center of the steel, whatever is there, that is effective depth. This much. Small d. Small d is effective depth. Now, while designing in limit state method, some limit state of collapse, for designing limit state of collapse are there, has been used. So limit state of collapse or limit state of collapse. There are 4 limit state of collapse. For flexor, it is as per IS 456. Then for shear is also part of a design. Always remember, flexor means for bending moment. This is for shear. Third one is for torsion. And then for compression. Column. Compression means column. These are the limit state of collapse. And some limit state of serviceability. This thing has been used for design purpose. And limit state of serviceability there are 2 which has been used for checking purpose, and these are for deflection and cracking. For deflection, so you know deflection should not be more than what is the allowable limits are there, and for cracking we are having some maximum spacing, minimum spacing, then minimum reinforcement, maximum reinforcement, nominal cover. All these things are related with the limit state of serviceability cracking. Always remember this thing. Deflection we know, but for cracking we are having reinforced covers, reinforcement, and spacing. All these whatever has been mentioned in our IS 456, it is according to limit state of serviceability cracking. Now we'll discuss some questions. In general, it has been asked in our GATE, ES, or other competitive exams. So some objective questions are there, 1 marks, and then 2 marks, for which we have to find out the answer. So the few questions I will discuss with you. So it will be come to know that how they are bluffing. Yeah, what is the way to understand the language and other things. One question I will write, and then we will discuss about it. The spacing of stirrups in a cantilever beam loaded a point load, loaded with point load at free end. It is something like that. A cantilever loaded with a load W at free end. So the question is about the spacing of stirrups. What will happen to stirrups spacing? A is increases near supports. Second one, decrease this near support. Then third one is depends on size of beam. And the last one is it's same everywhere. So here in general, what is our perception that it is a cantilever? So bending moment is maximum here. Here is the bending moment maximum. And so maybe some audience is there. Okay? I want to know that answer of that question. What did they think? Hello? Hello?
Yes, sir.
Yes, and anyone try to answer this question? The spacing of stirrups in cantilever beam loaded a point load at free end. What will happen? It is something like that. It will increase near the support.
It increases near support, sir, I think.
Acha, someone had answered that it is increases. What is the someone other else thinks about it? Any other answer? Okay. Now let us try to simplify and then try to find out the answer. It is a cantilever beam. So here load is W. So here the also load reaction will W. Left down, right up. So shear force diagram is something like that. W throughout same. WW. When shear force is same throughout, it is a bluffing question. Generally, we think it increases near the support, but no. It will not even decrease. It depends on not size up. It will be same throughout, same everywhere. And the reason is that the shear force diagram is like that for that. It is same everywhere. So that will be the answer for this. Now, one more popular question about the column and asked so many times that I will discuss. When the lateral dimension, there are two dimensions for the column. We can say least lateral, but it is the language given in the GATE exam. So same is the language I am using. When the lateral dimension of column means one of the side is 200 mm and dia of bar do not exceed 12 mm. 12 mm से ज्यादा नहीं होगा और कॉलम का जो डायमेंशन है 200 mm या उससे कम होगा. Then nominal or clear cover should be, what will be the value? In general, for the column we are using the clear cover 40 mm. For slab, it is 15 mm. For beam, it is 25 mm. For column, 40 mm. And for footing, it is 50 mm. But here 4 options are given: 25 mm, 30 mm, 35 mm, and finally 40 mm. But this is a special condition. When the least lateral dimension is 200 mm or less, but here 200 mm they had mentioned, and dia bar will not exceed 12 mm. So in that condition, we have to use, because it is a sleek column, we have to use 25 mm. This is the correct answer. So many times they are asking this question in our competitive exams. I am having so many questions, but some questions have 2 mark also. I have to discuss. So I will take 1 2 marks question here now. We know about the T beams. T beams are generally used in RCC. So T roof section.
Sorry to disturb, sir.
Yes, please.
Sir, as per IS 456/2000, there will be a note given in below the table number 16 that if your main reinforcement dia is up to 12 mm, then for mild exposure, the nominal cover may be reduced by 5 mm. So as per that
It is
condition,
there,
if
but
we are
suppose they had asked the question like that and they had given the options like that, then we have to choose from them. And it is, they had mentioned that actually it is less than 200 or less than 200, then also it is 25 mm. One of the least lateral dimension, one of the dimension. But it is in the gate, it is been asked the same language I had used. That is okay, what you are telling, it is correct. But here it is 25 mm for that. It is clear cut mentioned in our IS code. We have to strictly follow the classes of 456 2000. Okay.
okay, sir.
Okay. So now I will try to take one problem. Generally, they are asking for 2 marks. So T roof section has following particulars. Has following particulars. Now see how they are bluffing with the data. That actually I want to show you that thing. First is here they had given this particular thickness of slab 100 mm, width of rib 300 mm, then depth of beam 500 mm, effective span or span, whatever we follow the language, 6 meters, and finally the distance between point of contraflexure 0 moments is 3.6 meter. Calculate or find width of flange. We have to find out BF, width of flange. They are not given BF notation, but I am here mentioning about it. So now you see here, they had given thickness of slab, width of rib means BW, then depth of beam. Here nothing to do with this data. They had given for the bluffing. The effective span of beam, that is also for bluffing. Actually, between T to T, the formula is BF is, we know L0 upon 6 plus BF, then BW. then 6 times DF. So here we will utilize only these much data, this 100 mm, these data, and this 3.6. Unnecessarily they had given this data. Here also they had given 4 options, but I will tell you the calculation here. BF will be L0 means this 3.6 distance between the point of contraflexure. 3.6 multiplied by 1000 in mm by 6 plus BW. This is width of rib. They had not given directly width of rib. They were used the word width of rib. It is your here C 300 plus 300 plus 6 times depth of flange. It is nothing but depth of slab. So multiplied by this, you are 100. So it is 600. If possible, directly we have to calculate, and it is finally 1500 mm. This will be the answer. Sometimes they are asking like that, without they are not giving any option, and we have to find out the answer. So this will be the answer for that. Here L0 is this, the distance between point of contraflexure, T to T. The effective span is the different thing. That is for T here in longitudinal direction. But distance between two T will be L0 that we have to consider. Here, suppose sometime they are asking similar type of question in 4 options. They are giving like that. A 300 mm, 3000 mm, then 1900 mm, C 1600 mm, and D 1500 mm. So correct answer will be 1500 mm. Like that we have to calculate. Either like that or like that also they are asking question. Like that also they are asking. Means that then we have to solve the problem and we have to find out the answer. Suppose they are not giving any option. It becomes difficult because we don't have any choice. But always when we learn the things now, so whenever some question is there, don't try to directly try to answer it. You see some code, you try to use the book and try to learn the here and there. Means at least 10 to 12 things you will learn at a time. Someone where prepare the question, a lot of study has been done by the persons to solve the problem. Similar way, I want to take one pre-stress problem also that, but now I think much more time has been I have taken, so I will finish my lecture. So all the best to all of you, and thank you very much.